Hi everyone, welcome to my YouTube channel. Today I am going to discuss with you a numerical problem related to classification of soils. How soils are classified according to Indian Standard Soil Classification System. Let us see how it can be done. This is the numerical problem given to you to solve it. First, soil has gravel, sand and silt size, but uniformity coefficient and coefficient of curvature are not defined. Second, soil has all fractions given, but it doesn't have liquid limit and plastic limit. And soil 3 has soil fractions, all those soil fractions, but it does not have uniformity coefficient and coefficient of curvature, but it does have liquid limit and plastic limit. Indian Standard Code IS 1498 1970, which is the code for classification of and identification of general soils for general engineering purpose. So if more than 50% of the soil retained on 75 micron ISF for sieve analysis, dry sieve analysis, so it will be considered as coarse grained soils. If more than 50% passing through 75 micron ISF, it will be defined as fine grained soils, and all other soils and with highly organic matter which are defined as peat soil. And these are the notations for defining the soils given here, and it has well graded subgroups also, well graded, poorly graded, etc. These are the codal provisions given there. And if the liquid limit is more than 50%, the soil that is defined as highly compressible, defined with capital H. And here this chart shows you based on grain size how the soils are classified. As I mentioned, there are cohesive and cohesionless soils, and mostly it comes under fine grained soils, cohesive soils, and then cohesionless soils. And the primary divisions are also given with the group symbol. Well graded gravel is denoted with the GW, poorly graded gravel GP. Likewise, for clay sand it is defined as SC. So these are the things you should remember. And for coarse grained soil, again there is provision for defining it with well graded gravel or poorly graded gravel, or silty gravel or clayey gravel, and silty sand and clay sand. So for here, as I mentioned, more than 50% of coarse fraction is larger than 4.75 mm. That is which retains on the 4.75 mm, more than 50%. Then it is termed as gravel, that is capital G. If more than 50% of coarse fraction is smaller than 4.75 mm, that is which passes through 4.75 mm, it will be defined as sand and with the letter capital S. Here also uniformity coefficient is greater than 4 and coefficient of curvature 1 to 3, it comes under GW, that is well graded gravel. And on the other hand, if uniformity coefficient is greater than 6 and again coefficient of curvature 1 to 3, then it is coming under well graded sand. If the fines are here, the condition is if the fines are less than or equal to 5%. Okay, here again this comes, if the above condition is not met, this will be termed as poorly graded sand. Here also poorly graded gravel. And if the fines are more than 12%, then these symbols are used, that is silty sand, clay sand, and silty gravel and clay gravel. This you must remember. And in one of the previous videos I mentioned about these things: uniformity coefficient, how do you calculate, and coefficient of curvature. Okay, these parameters we get from sieve analysis. These are we can get from grain size distribution curve. Okay, grain size distribution curve. And dual symbols are also used. If equal percentage of coarse grained and fine grained fractions are available, then you can define the soils according to this. Here it is silty gravel and low compressible silt. Silty gravel and intermediate compressible silt, and silty gravel, medium compressible silt. So fine grained soils are classified with low compressible, intermediate compressible and highly compressible. Okay, for fine grained, that is clay and silt. Here again, if the fractions are falling between 5 to 12%, 475 micron ISC, then again this is notations are different. That is well graded gravel and silty gravel, well graded gravel and clayey gravel, like that. So it goes on like this. This is the plasticity chart which was developed by Casagrande. This is very useful for classifying the fine grained soils. As I mentioned, if the liquid limit is less than 35, the soil or is termed as low compressible. It is between 35 to 50, it is intermediate compressible, and if it is greater than 50, it is highly compressible. And the parameters which are given to you are liquid limit and plastic limit. You can calculate the plasticity index, that is IP here. Okay, that is nothing but liquid limit minus plastic limit. Okay, then the A line equation is this. You can substitute the value of liquid limit into this. You will get again plasticity index value here. Okay, and here it is liquid limit, and you can calculate 0.73 into WL minus 20. So this we can keep as denote as 2. Okay, here you can you will get two values for plasticity index. So you can, if the calculated value, this one P1, is above or below the A line, okay, it may be here or it may be here. So accordingly you can define the soil. Okay, it may be clay or it may be silt or clay. Okay, let us see how this can be solved. Okay, for the first soil here, you can see here the data are given here for soil 1. Okay, gravel size 4%, sand size 7%, silt and clay 89%, and CU and CC are not defined for this, and liquid limit 55 and plastic limit 23. This is the plasticity chart. The percentage of silt and clay, that is more than 50%. So here you can say it is fine grained soil. And you see the second condition is liquid limit. If liquid limit is more than 50%, the soil is defined as highly compressible. Now the plastic limit is given in the question. Okay, that is 23%. You can calculate plasticity index. Here it is 32%. Okay, and according to the equation corresponding to A line from the plasticity chart, this is the plasticity chart. Okay, this is the plasticity chart. Okay, so you can calculate the value of plasticity index, that is 25.5. That is less than what we have calculated earlier using the data given. Okay, so it means that we can just locate these values here. So liquid limit is given as 55 somewhere here. Okay, liquid limit is given as 55 somewhere here. Okay, somewhere here liquid limit. Okay, WL which is given. Okay, now the calculated value of plasticity index is 32%, maybe somewhere here. Okay, so then you can just locate it This may be the point corresponding to this. Okay, this value is above A line, it means it is clay soil. Okay, and it is coming under CH, coming under the region CH. Okay, so the soil is CH with highly compressibility. Okay, this is the answer for the first soil. Okay, you need to remember, you need to locate the calculated value, okay, and given liquid limit value in this chart. Okay, you can easily get, even without that also it can be done. Once you practice this, you will be able to do without the plasticity chart. Okay, now we will move to the second question. Okay, in the second question, here gravel fraction is given as 2, sand fraction is 95. Okay, and the percentage passing through 75 micron is 3%. So you can calculate what is retained on 75 micron. 75 micron, how much retained? So you know that gravel fraction and sand size, sand fraction will be retained on 75 micron. So that is this. So more than 50% is retained on 75 micron. So it is coarse grained soil. Okay. Now here you have sand, that is 95%. Okay. More than 50% is sand in this case. So more than 50%. So more than 50% is sand. Okay. So this one is more than 50%. Alright. So you can calculate, you can define it as sandy soil. Okay, if it is more than 50%. Now, silt and clay fraction are less than 5%. Okay, and you know that the condition for coarse grained soils are given here. Okay, so the Cu which is given is less than 6% and Cc is 1.5, between 1 and 3. So less than 6% means this condition is not met. Okay, so it is defined as poorly graded. Okay, so now you can easily, the percentage fine is less than 5%. Percentage fine is less than 5%. So it is termed as poorly graded soil. Okay, the percentage fine is less than 5%, so it is poorly graded. So this is the answer. This is exclusively for coarse grained soils. Okay. Now we move to the third set of soil parameters. Here again, gravel is 6% only, sand is 3% only, but silt and clay fraction is 91. It is more than 50%, so defined as fine grained soil. Now liquid limit. Liquid limit is less than 35%. Less than 35% is here. Less than 35%, and that is less than 35 means you have low compressible, this portion. This is low and this is intermediate and this is high. So this is the difference. So 50%, between 50 and 35 is intermediate, greater than 50 is highly compressible. Okay, here it is given liquid limit is less than 35, so it is low compressible. Alright, then plastic limit is 25% given in the question. Now as usual we have done earlier, we can find out the plasticity index, that is 5%, and value on the A line is 7.3. Okay, the plasticity index is 7.3, which is calculated using the equation for A line, but we got the value as 5% from the data given. So 5% is somewhere here. Okay, somewhere here. All right, so it is below A line, and the symbol corresponding to that is M. Okay, M. So low compressibility it has, but the value which is coming under the below the A line value is 7.3, but we are getting somewhere it is 5 somewhere here. Okay, somewhere here. So we have silty soil, it is M. Low compressibility means it is denoted with L, M, L. Okay, this is the answer for it. And there is a portion which is shaded over here. This is dual symbol for this. It is Cl, Ml. So if suppose you got this value above A line, okay, above A line, and the plasticity index is somewhere even around less than what liquid limit is around less than 20. Somewhere here you will get the value. Then it is termed as ClMl. That's special case. This is dual symbol actually. So you need to remember all these things. It's very much required for the examinations. After you practice it without the plasticity chart, you can easily do any kind of problem related to this. This was asked several times in competitive examinations also, in the university examination also. Okay. Thank you very much.